Hello guys, welcome back to Meson African Motives, still on our mathematics N5 revisions. This platform we shall be working on the maxima and minima, that is the application of maximum and minimum turning points. We've got a lot of questions that we shall consider in this class that we shall have. Just a basic introduction of our maximum and minimum values. What is it that we are actually referring to when we are talking about the maximum and minimum values in this case? All right, so I'm just going to introduce this from our normal functions if we are given a curve so that we can understand the basic part. If you are given an algebraic function, let's say this is a cubic function, which is best for us to talk about this at the same time. Our graph can be taken whereby it is going to be at a certain point as it is increasing its values. It is going to reach a certain point whereby it's no longer increasing, it's just stationary at this point, which is referred to as the maximum turning point. From that point, we'll see the graph starting now to decrease up to a condition whereby again it is going to be stationary, constant, no movement at all, which is referred to as the minimum turning point. Then it starts again to increase. So we are saying at this point, this is where it has reached its maximum value. The function has reached its maximum value. There is no movement at this point. So it's a turning point having a maximum value, and this one is a turning point having a minimum value in terms of y. With the applications that we talked about from our normal functions, we said at any turning point, we're saying the first derivative there with respect to x is supposed to be equal to 0, whereby we are talking about the gradient expression dy dx must be equal to 0. This same application is going to be the one that you're going to use, because at the turning points, we are talking about being maximum or being minimum in this case. So if it is the case, it follows to say whatever that you're going to say it is maximum or it is minimum, whether we are talking about area, maybe you're talking about in terms of area in this case, we are talking in terms of volume, you're talking in terms of cost, we can talk of whatever that can be maximum, whatever expression that you're going to have. That expression, when differentiated, must give us a 0. Let's say you have got an area of a certain shape, you express your area in terms of x. Maybe that area in terms of x is given as x cubed or 2x cubed. You have formulated a certain formula in terms of x. For this area to be maximum or for this area to be minimum, it means the first derivative of this area with respect to the x, the part that you have written in terms of its with respect to x, that is what matters. It must be equal to 0. If you write this expression in terms of y, maybe you've written your area in terms of y, maybe it's 4y squared. This is the expression of area, or an expression of volume, or an expression of cost. For this area to be maximum or minimum, its first derivative with respect to y must be equal to 0. So what you need is to formulate an expression for what is to be minimum or what is to be maximum. Is it area? Is it volume? Is it cost? Determine an expression in terms of a certain variable, maybe in terms of x, in terms of y, in terms of whatever that you're given. Then you determine its derivative, equate it to 0 for maximum value. So this is the whole idea of maximum and minimum value. So let us consider this with the questions that we have that we are going to consider. The first part of our questions that we are going to consider here is given that a rectangular storage area is to be constructed along the side of a tall building. In this case, we've got a tall building that we have in this case. Then we are given that a security fence is required along the remaining sides. So on this building that we have, we are going to put a security fence. So this diagram here, we are not supposed to have this part here. This part is not, it's part of the building, this one. It's part of the building. This part that we see here, it's the building, part of the building here. The fence is going to be for the remaining 3 sides of the area, meaning to say our fence is going to cover from this point up to this point, up to this point, up to this point here. That is where our fence is going to cover X, Y, and this X. So we are given on this platform that what is, take note now, what is the maximum area that can be enclosed with 800 meters of fencing? All right, this is our idea here, guys. Let us consider our question. We said for the part that is supposed to be maximum is what? It's area. We are supposed to be talking about area being maximum. I want us to understand this part. All right, so our area is supposed to be maximum. And for this area to be maximum, it means we must have a derivative of the area with respect to a certain, like what I was explaining here. Maybe you write in terms of X, you are going to write in terms of Y, whatever part that you're going to have, but the derivative of that area must be equal to 0 for it to be maximum. So in this case that we have here, let us consider what we have. We are told that the area is supposed to be maximum, but we do not have an expression for that area. So we are supposed to formulate an expression for area, or the formula for area in this case, formula for area. So by formulating an expression for area, it must be in terms of one variable, either in terms of X or it can be in terms of Y. So where are we going to have this area? In our normal sense, we know that the area of a shape, this is a rectangular shape that we have. The area is supposed to be equivalent to the length times the width. In our normal sense, this is what we know, length times width, or the length times the breadth. We are talking about the rectangle. You can talk of width, or we can talk of what? Of breadth. So in this case, our length being the longer side, we can take X, we can take Y, in this case, whatever part that you can write in this case. So even if you write as Y times X, at the end, Y times X is same as what? Is same as XY. So meaning to say, this was supposed to be the expression of the area of this rectangular fencing that we have. The rectangular fencing, the area I talk about, what is inside. Take note, area and perimeter, they are two different things. Whether this part is being taken by a building, the building has got its own area. Whether this part here is for the building, it does not affect our area for the fence. The part that is the space inside, this part that is covered inside, what you see inside, that is your area. So the area is not affected by, to say this part is not covered or what. No, does not affect our area. If we are to see our area, it's written in terms of X and Y, and it's difficult for us to obtain the derivative because I said it must be in terms of either X. So you find derivative of area with respect to X, which is equal to 0, area with respect to Y. But in this case, we can see our expression consists of X and Y. So what are we going to do so that we remain with either X and Y? We go again to the statement that we are given before. Before we are told that a security fence is required along the remaining three sides, which means this side X, Y, and this X. These are these three sides. And that area and that fencing that is required, it is 800 meters. 800 meters of fence, meaning to say this is the fence from this point to this point up to this point. This is the fence that was covering up. So if we are to add X plus this Y here plus this X here, it must give us the total length of the fence that was covered. This is now perimeter, the part that the fence is covering, distance right round. The fence is not covering this part. This part is having the building. The part here is not covered because they say the fence is covering the three remaining sides. So this is the part that was covering the fence. So meaning to say here we've got an expression for X and Y. This is 1X, 1X. We're going to have 2X plus Y is equal to 800. This expression now is, this equation is the one that you are going to play around. Since you want to write your area, either in terms of X or here you choose, it's your choice. You choose which one are you going to write your area in terms of. So you just make the subject from this part, whatever that is easier for you. So in this case, as you can see, it's easier for us to make Y the subject, and for us to transpose Y, then we divide by 2, whatever part is going to be a lot. So instead of avoiding working, yes, you can do that. I'm not saying it's bad. but just try to avoid. So you can simply make y the subject, meaning to say y is going to be equal to 800 minus 2x. We are now having an equation or the part that is representing y in terms of x, so that we can rewrite our area in terms of x. So our area now in terms of x is going to be written as x times y. What is the expression for y in terms of x? Y in terms of x, it's 800 minus 2x. If we write this area in terms of y, therefore it shall be area in terms of y is equal to, meaning to say if we had to make y the subject, we're going to have something like, if we had to make x the subject, it was going to be 2x is equal to 800 minus y. You divide by 2, by 2, by 2. So meaning to say our x was going to be 400 minus y over 2. We substitute in place of x, meaning to say your area, if we substitute x in place, we are going to sub this part here, which is y. So meaning to say our area is going to remain in terms of y, because this x here is now replaced with an expression for y. So we are going to write as our area in terms of y is going to be the part that is y times x, our x, which is 400 minus y over 2, like this. Still, you are going to obtain the same concept. This time you're working with y, you find whatever that you're going to get for y. So that is what I'm simply saying, that you choose the part to make the subject. So in this case, as you can see, we are working with fractions, which is fine. You can work with these fractions. Still, we are going to obtain the same thing. So here, we're just going to choose this one where we do not have fractions. You can see this one is in terms of x. That's why I'm writing area in terms of x. So you can expand our brackets by x. We are going to have 800x minus 2x squared. So this is the expression for area. And we are saying for this area to be maximum, what does it mean? It means the derivative of this area to be max, it must be equal to 0 for area to be maximum. All right, so for this area to be maximum now, that is where we consider its derivative. The derivative of area with respect to x must be equal to 0. So we are going to find the derivative now with respect to x. We are having our area in terms of x. So this is going to give us 800 minus 2 times 2 here, which is going to give us a 4. So that is going to be 4x. We subtract 1. Remember the derivative concept. This is equal to 0. So from this part, we can calculate x minus 4x is going to be equal to 800 to this side is going to be minus 800. You divide by negative 4. So that means we are going to obtain our x as 200 in this case. Having the value of x, remember we need the area in this case. We're going to take this value of x, we substitute it into this equation where we have already made y the subject of the formula. We can easily substitute it there because there y is the subject. So from this, we are saying y is going to be equal to 800 minus 2 times x, whereby our x is 200 in this case. So if we simplify this, y is going to give us 400 in this case. All right, let us take the units here. We are given meters. So meaning to say this x and this y, they are being measured in meters in this case. So we have got the x at maximum value in meters, y at maximum value in meters. But was this the question? Is the question asking you to calculate the values of x when the area is maximum? No, our question is, let us go back to the question. Our question is, what is the maximum area? What is the maximum area? So we are saying for our area to be maximum, the first derivative must be equal to, and we obtained the value of x. When the area is maximum, our x is 200. When this same area is maximum, y is 400. So therefore, we can determine our area. So therefore, our maximum area, our maximum possible area in this case is going to be, remember we said our area is x times y. So we have the value of x, which is 200 times the value of y, which is 400. So that is going to give us now the maximum possible area that we can have, which is going to be 80,000. So we're going to obtain something like 80,000 in square meters. That was the whole idea of this question. That is the whole idea of maximum and minimum values. The first derivative of that expression that you have must be equal to 0. So what you need is to formulate an expression for what is to be maximum or what is to be minimum. I want us to consider this question here. We are given a similar condition like the previous part. We are given a farmer wants to enclose a field with length and breadth, X meter and Y meter respectively. So this is a field, it's a rectangular field once we're told about length and width. So this is what we have. We've got our rectangular field in this case, given that the length of the rectangular field is given as X, because we're told respectively length and breadth. So this is the length, this is the breadth. So our length is X and the breadth, which is the height of this, is Y in this case. All right, so this being our length and this being our breadth, which is what? Which is the width. So we are given that the cost of fencing is 36 Rand per meter. Take note, it's per meter, meaning to say we're talking about per length. For the length, if you're dealing with the length, it's going to be 36 Rand per length, 45 Rand per breadth. So meaning to say, let us just maybe write it aside. All right, so for the cost, it is going to be 36 Rand per what? Per meter in this case, whereby we are talking about length, and length is referred by what? By X. So this is going to affect X. All right, the same cost, we are going to have 45,000 on the cost, 45 Rand, sorry, per meter. This affecting the breadth, and our breadth in this case is represented by Y. Then he has, take note, what guys, be careful when you're answering question. He has an amount of 56,000. This is the amount that he has that is available. So meaning to say the total amount that he has, or the total cost that he is having in this case, the total amount that this guy is having is what? We are given the total amount of, all right, that's a U there. Okay, that's 56,000. So we've got 56,000, right? This is the total amount he is having after finding this to say each meter cost 36 Rand for the length, and for the breadth 45 Rand. It means we can even formulate an expression from there. Okay, let's forget about that. Let's go to the question. Okay. 3.21, give the formula for the area and the cost in terms of X and Y. All right, we need two formulas here. One is going to be for the area, and the other one is going to be for the what? For the cost. But these formulas must be given in terms of X and Y. All right, let us take the one for the what? For the area first. Is direct, this one. All right, so for the area, that is, we can just have it here, 3.21. So for the area, we are going to have this as length times width. Remember, length times breadth. So that is going to be length times breadth in this case, which is length, it's X. Our breadth, it's Y in this case. So this is going to be X times Y. That's the expression for area measured in meters. So you can just write our A is equal to XY. So we can't write here. We can, if you want to write to say your area is in terms of X or in terms of, you can write it like this, but just leave it like that, because here we've got two letters that we are considering. Then what about for the cost? Because we need area and also need for the cost. So the cost, what is going to happen? Let's take note about the cost. They are saying it is going to cost us 36 Rand per meter for X, which is the length. So meaning to say we do not know the length that we are going to have at the end. Is it going to be 5? Is it going to be 7? But we know that the length is represented by X. So if each meter is costing 36, what about X meters? We are going to multiply 36 times X, meaning to say 36, X meters is going to cost us 36X Rand. We move on to the width. If each meter is costing 40 Rand, what about Y meters? We are going to have 45Y in this case. We just have to multiply the two. But let us consider to say this is the cost for a length, which is this one. But this rectangle, we have a length also here. We have a breadth also here. So what is going to happen is that we are going to multiply by 2, because we have got the length on this side, another length there affected. It's a cost and another cost. So this one is going to be multiplied by 2. this one is going to be multiplied by 2. That is the condition there. So that means at the end, 2 times 36 is going to be what? 72x plus 2 times 45, which is going to be 90y. So this is the expression for the cost, which is going to be equal to this amount if we are to write. But in this case, we just want an expression that is representing cost in terms of x and y. In terms of the total amount, this is the total amount, the one that he is going to consider. But in terms of x and y, this is what we are going to have in terms of x and y. So these are two different things, meaning the same thing. We have got a numerical value and we've got an expression for the cost. All right, that was the first part. 3.2, to calculate the dimensions of the field with the maximum area. All right. This is what we have, guys. Be careful, like I was saying. Now we want to calculate the dimensions. What is the value of x and the value of y? Because these are our dimensions, x and y. But these dimensions should be from maximum area. So it is the area that we are supposed to work with in this case. We are supposed to be focusing on the area for it to be maximum. What is the condition? The first derivative of the area must be equal, but with respect to what? That is the question. With respect to what? Is it with respect to x or with respect to y? That is what you need to ask yourself now. Is it with respect to x or it's with respect to y? So if we are to consider, this part is no longer important. All right, I just need the cost here before. All right, I just need this cost here. So if we are to consider from our previous case, we said our area is in terms of x and is in terms of y. So how can we write this area in terms of x only or in terms of y only? We have to substitute, we have to eliminate the any part, substitute with another expression in terms of x or in terms of y. From where? We have another expression for cost. So this is the expression that we are going to play around with. Because we don't want anything that is going to give us maximum cost, no. So from this cost, we are going to use it now to give us either x or to give us y. All right, so I'm going to take this cost here. Remember our cost, we said it's 72x plus 90y. This is the money that is going to be used. But this guy, in terms of the actual amount, it is 56,000. So this cost must be equal to 56,000. Meaning to say, I have formulated an equation from the cost. The total cost must be equal to the amount available. So from this, I can make either x or y the subject, all right? So let's say I want to make x the subject. I can transpose the 90 to the other side so that it can be a negative there. So I'm going to remain with the 72x is equal to 56,000 minus 90y in this case. So to find x, we can simply divide by 72 by 72 by 72 in this case, each and every term. So our x at the end is going to give us what? This was going to give us decimals. So I'm just going to avoid the decimals because we round off. It's going to affect our answer. So I'm going to work with the fraction, no problem. So I'm going to take this as a fraction, 7,000 over 9. So here we're going to obtain 7,000 over 9 minus this is going to give us 5 over 4. So it's going to be 5 over 4. 5 over 4y like this. All right, so this is an expression that we're going to have of x. X is equal to this part here that we see. So meaning to say on our area, we're supposed to have our area in terms of x and y as xy like this. This was supposed to be our normal expression. But we have made x the subject, meaning to say once we substitute this x, we are going to substitute our x with y. So our area is going to be in terms of y because this x is no longer there. We are going to remove this x. We substitute this part that carries y. So our area is going to remain now in terms of y, which is going to be this y. We are not substituting. We are not replacing this y. We are replacing this x. So it is going to be x times this y. So x here is what? It's 7,000 over 9 minus 5 over 4 times y in this case. So that's the idea. So we have our expression for area, presentation for area in terms of y. You are supposed to formulate either in terms of x or in terms of y. So this is same as y over 1. We multiply on top. So if multiply, this is going to be 7,000 over 9 times y, in this case, minus y times y. Here we are going to have y squared. So we are going to have 5 over 4 y squared. So we have obtained an expression for area, but they are saying we need to calculate the dimensions of the field with the maximum area. So for this area now to be maximum, for this area to be maximum, its first derivative with respect to y must be equal to 0 with respect to what you have here. We couldn't apply it here because we've got x and y. That is where we have to search for another equation that has got x and y also, so that we can make substitutions to replace one of these. So we can have our derivatives there. So the derivative of area is going to give us what? This one is going to give us 700, or you can even just calculate direct here. The derivative of area, which is going to be 7,000 over 9. Here we've got a linear part y there, so it's going to take the constant. All right, minus, remember, we have to drop the exponent, then subtract 1. So it's going to be 2 times 5 over 4, which is going to be 5 over 2. It's going to be 5 over 2. We subtract 1, so it's going to remain with y. So this is our first derivative of area. And we are saying the first derivative of area is supposed to be equal to 0. So we have formulated an equation that we can be able to solve for y in this case. We can solve for y, whatever way that you're going to have, minus 5 over 2y is equal to 700 over 9. It's going to be a negative. So to remove this, we're going to divide by minus 5 over 2 both sides. We divide by this minus 5 over 2 this sides, all right? So that means at the end, y there was going to give us 311, something like that, 311,111, like that. That was going to be the value of y in this case, or as a fraction, or as a fraction. Okay, but you can just write as a decimal. I think that can be the best if you are dealing with the dimensions now, because we are putting back your dimensions. And let us check, what is this x and y representing? Is it meters or what? It's per meter, whatever that we have here. X is per meter, y is per meter, y is measured in meters. So meaning to say our y was supposed to be 311,111 in meters. So where are we going to have the value of x? Already we made x the subject of the formula here. So on this subject that we have made x the subject, we are going to substitute the value of y that we obtained, because we have obtained the numerical value of y now. So all we need now is to simply substitute this value of y that we are having here. So that means at the end, y was, x is going to be equal to what? X is going to be equal to 7,000 over 9 minus 5 over 4 times y. So it's going to be 5 over 4 times the value of y that we got, which is 311,111 in meters. So that was going to give us the value of x, which if you round off to 3 decimal places, in this case was going to give us 388,889 also in meters. All right, so that was the idea of our question. We have the value of x and we have the value of y, which corresponds when our area is maximum. When our area is maximum, calculate the dimensions. So our question was to find the value of x and the value of y for this area to be maximum. What is the value of x and what is the value of y there for this area to be a maximum? So like I was saying, it's a matter of formulating the expression for the one that is supposed to be maximum. Is it volume? Is it cost? Whatever that you're given there. We have another question that you're supposed to consider here. We want to build a rectangular box. So this one is a rectangular box, not just a regular. We're talking of volume there. It's a rectangular box. All right. So meaning to say, in this case, if it is a rectangular box, we are going to be focusing with the volume this time. It's different from a rectangle. A rectangle is just a normal plane shape, but when it is a box now, it's now a solid in this case. So for a solid, we are supposed to consider what the volume, we have got the base area times the height of that box in this case. So we are given that this box that we have, it has a base length 6 times the base width. All right, so this is the width and this is the length and this is the height in this case. So they are saying the length is equal to 6 times the width, an expression that we are given. The height is not affected. It's going to remain as it is. So meaning to say wherever we see this length, it is going to be 6W in this case, 6 times the width, of which you can write the base width, or which is the width as B, the breadth, like for B for the breadth, or you can just use W for what? For the width. It's just one and the same thing. And we are given that, and the box will enclose 20 cubic meters. We are given the volume, cubic meters. These are the units for what? For volume there. So meaning to say we have the volume of 20 cubic meters. In this case, we're given our volume to be 20 cubic meters. Then the cost of the material of the size, take note the cost, how it is given, 3 rand per square meter. It's square meter. What are we talking about here? Square meter. We are talking about area, not per length. Last time it was a cost per. It was cost like whatever cost, 36 rand per meter. That was the cost per length, per width. We are talking about per meter. That is the length for the width. But now they're saying per square meter. It's no longer per unit length. It's now per area. So the cost that we are given is given per area. So the cost is given per area. In this case, we are given the cost per area, which is given as what? As 3 rand per square meter. That is the idea. It's per area. And this is affecting, take note, this is the cost of the sides in this case, all right? So this is the cost affecting the sides of the shape. Okay, the sides we're talking about, this side here, this other side, this, what we see on this, and what we see on the back, on this side of the back here, what we see on the back, not the top. The top is left. So we are talking about the sides in this case. Then the cost of the top and the bottom, that's 15 rand per square, again, per square meter, per area again. So we are going to have another cost of 15 rand per square meter, which is now for the top and what? Top and bottom. All right, this is the information that we were given. Now the question is, from this information, take note. Determine, our question is to determine the dimensions of the box. We need the dimensions. We need to know the length. We need to know the width, which is the breadth. We need to know the height of this. But these dimensions, that will minimize the cost. That will minimize what? The cost. The cost is the one that we are dealing with in this case. It must minimize the cost, not the area, but the cost. So meaning to say, in this case, we are going back on our information to say, we are supposed to minimize the cost. So meaning to say our cost is supposed to be minimum. So for this cost to be minimum, we need the dimensions now. So we are supposed to find an expression for cost in terms of one variable. We can find our cost in terms of the width, which is the breadth in this case. Remember this part here, the W there is representing what? The breadth. Most of us, we are used to the breadth, or the width is just one and the same thing. So meaning to say, in terms of the width, our cost can be written in terms of the width, we do not know. Our cost can be written in terms of length, we do not know. Our cost can be written in terms of height. What we just is an expression for the cost in terms of these, so that we can find its derivative. So let us start stage by stage. All right, let us see this one stage by stage. What are we going to do? First, we have got the volume. We know this volume was taken from what? Because the volume here, it consists of the length, the breadth, and the height. The length, the width, and the height. In this case, these are the ones that give us what? The volume. So from this volume, it was given as length times breadth times height, which is length times, here we are using the width, So it's going to be length times width times height, which is length times breadth times height. One and the same thing, all right? So our volume being 20. So 20 is equal to the length times the width times the height. But we are given that the length is equal to 6 times the width, which is the breadth. So our 20 now is going to be equal to, in terms of length, we are going to substitute 6 times the width. So it's going to be 6 width W times H, meaning to say we are going to have 20 is equal to 6W squared H. So from this part, what is it that we are actually obtaining from this volume? What is it? We can just make H the subject, since it's difficult for us to make this W the subject. So we are going to make H the subject. So we can just divide by what? 6W squared both sides, 6W squared. This one is going to cancel. So our H is going to be given as what? If you divide by 2, that's going to be 3. Or just on your calculator, guys, it's going to give us 10 over 3. So meaning to say we are going to obtain 10 over 3 width squared or breadth squared. Remember, W represents the width, which is the breadth. So with this information that we are having here, we are just limited because we just got an expression for the height, which is just fine. All right. Now we move on to the other part. We said we need to find an expression for the cost, but our cost here, it is given per square meter. So meaning to say the cost is covering whatever every part area. We're talking about the total surface area in this case. That is the one that we are dealing with. So this is that you are simply going to calculate the area, the surface area of everything. And you're talking about, or we are referring to a rectangular shape in this case, that is a rectangular prism, whereby we know that the surface area. So what our area is the one that is important. What Mark say our cost in this case is the one that is important. What is going to maximize our cost? So like I said, this one should be taken from what? From the area. So the first thing, let us have an expression for this area. So our area is supposed to be taken from where? From all the part that is happening. In this case, we say the top and the bottom. So the top and bottom, we've got length and width. So it's going to be 2 into the length times the width, which is the length times the breadth in this case. Then we also have the height and the width in this case, and also the height and the length in this case. So these are the parts that are happening. So you're going to have plus 2 times the length times the height, plus 2 times the width times the height, which is the height times the width, which is the breadth in this case. So these were supposed to be the sides, whereby this is representing the top part. Remember, it's supposed to be taken from the top and bottom. So this is representing the top and bottom. And these are the remaining sides that are affecting our shape in this case. These are the remaining sides. Remember, our top is from the length and the breadth, the bottom and the top, length and breadth, which is length and what? And width. So we have this expression, but we are told here, we are not supposed to be talking about area. We want what minimize the cost. So what is going to be the expression for cost from this expression of what? Of our area that we have. We can simplify our expression for area, or we can just have this as the expression for cost now. So our cost is going to be for the top, because this is the top and bottom. For top and bottom, we are charged 15 rand per square meter. So it is going to be 15 times this area that we have. So it's going to be 15 times this part. So we're going to multiply 2 times length times breadth, plus for these sides that we see, the whole of this part, we are going to be charged 3 rand per square meter. So this is going to be multiplied by 3. This is going to be multiplied by 3. So this is going to be 3 into 2 times length times height, plus 3 into 2 times width times height, which is breadth times height. This is supposed to be an expression for cost, but like I said, this expression cannot work because it has a lot of variables. We've got length, we've got width. We are supposed to write either in terms of width, in terms of length, or in terms of height. So all we need is to substitute whatever that we have that can be written. If we check, we have got our length in terms of width. We have got our height in terms of width. So meaning to say, in terms of length, we can write in terms of width. where there is length and height, we substitute the equivalent in terms of width. So meaning to say at the end, we are going to have the expression for the cost, which is our C for the cost, but now in terms of width, because we are going to substitute our length in terms of the width. So meaning to say, what are you going to have at the end? Let us multiply 15 times 2 here, we can multiply, that's it, 30 there. So it is going to be 30 times the length in terms of the width, it's 6W in this case, times W in this case. Since we are writing in terms of W, there's nothing that you're going to do here, plus 3 by 2, which is going to be 6 times the length in terms of W again, that is 6W, times the height in terms of W. This is our height in terms of W, which is going to give us 10 over 3W squared. Plus, we move on 3 by 2 here, that's going to be a 6 times the width. It's not going to change. So, to say, all we just need, guys, is to combine. All right. So, like I said, this was going to be 180W squared. Plus here, just multiply, but as you're multiplying here, you can cancel the W and W squared. That's going to be a W here. So also the 3 here is going to be 2. So you can multiply 6 by 2 by 10. That is going to be 120. So you're going to have 120 over W in this case, plus we do the same thing here. This one and this one can cancel. Going to have W 3 into this. That's going to be a 10. We multiply. So we are going to have 20 over W in this case. So as we can see that these are like terms that we have. So you can just combine our like terms, W and W. Common denominator is the same, so you just have to combine the numerator 120 plus 20, which is going to give us 140 over W. So this is the expression that we are going to have for the cost in terms of the width. Once we have our cost in terms of the width, therefore we can think now to say, what is the condition that is going to minimize this cost? It means the derivative of this cost that we see here in terms of width must be equal to 0. For this to be minimum, the derivative of our cost with respect to our width must be equal to 0. So we are supposed to differentiate. Remember, 140 over W is same as 140 W to the exponent of -1. So just have to keep that in mind. So let us find the derivative. We multiply here. That's 2 times 180, which is going to be 360. So we're going to have 360 W. Here we do the same thing, multiply by -1, which is going to be -140 W to the exponent. We subtract 1, so it will be -2. So this is the derivative of cost with respect to W, which must be equal to 0 for this cost to be maximum or to be minimum. In this case, we're told for this to be minimum. So what we need now is to solve for W. Solve for W. Since we are given an equation, this is now an equation you have to solve. All right, so we can just try to rewrite as 360W is equivalent 140 to that side is going to be 140 over W squared. Remember, to the exponent of -2 is same over W squared. So to find W here, we can simply cross multiply so that we combine the W's to one side of the equation, which is going to be 360 W cubed. So that will be a cubed here, same as 1. There's a 2 we add, which is equivalent to 140. Divide by 360 both sides. So W cubed is going to be 140 over 360. So what we simply need is to introduce the cube root to remove the cube there. Both sides, we introduce the cube root. We have the value of W that is going to give us what? The the minimum cost in this case. So our W at this moment, what are we going to have? It's going to be 0.7299. So if you round off, it's going to be 30 in this case. This is our breadth in this case, which is the width or the breadth in this case. Like I said, it can be given as the width or the breadth of 0.73. Remember, our question is not to find the maximum cost or the minimum cost. No, we need the dimensions of the box that will minimize the cost. So in this case, we calculated our width from this one. We obtained the value of what? Of the width. So meaning to say, we are supposed to find the height and the length. From where? From what we are given before in terms of W. Remember, here we've got our length in terms of W, which is 6W, our height in terms of W, which is 10 over 3W squared. So we're going to make substitution into these formulas in this case, all right, in terms of what? In terms of W. All right, so let us start with the height in this case. Let me just remove this part here. So the height, as we saw that our height is given as 10 over 3W squared, which is the breadth squared. So our height is going to be 10 over 3 times our W, in this case, that's 0.73. So you're going to square this. So this is going to give us the height, which is going to be 6.255 in meters. That is to 3 decimal place. The same condition for the length. In this case, we're given that length is 6W. So it's going to be 6 times our W, which is the width of 0.73. So this is going to give us the length, which is going to be 4.38 in meters. So these were the dimensions that we're going to minimize our area in this case. That's the whole idea. You just need an expression that represents whatever that is supposed to be maximum or to be minimum. With that expression, find the derivative equal to 0. We are done. So we have another part again here. We're given that the sum of the diameter and the height of a cylinder is 6 centimeters. All right, so we've got a cylinder in this case. Remember, on our cylinder, I've got something like this. All right, so there they are considering the whole part of the diameter in this case, the whole part, and this whole, the height in this case. So they are saying this height and diameter, they are related in such the sum. If we add, remember the sum, we add the diameter plus the height, we are supposed to get what? 6 centimeters. All right. Then the question is, calculate the dimensions of the cylinder to ensure a maximum volume, for us to have a maximum volume on a cylinder. We are talking about a maximum volume. The volume there is the one that is supposed to be maximum. Guys, the idea is still the same. For this volume to the maximum, what is the idea? The first derivative of the volume must be equal, but with respect to what? That is the question. The volume with respect to what? As we know that on a normal cylinder, our volume was supposed to be given by base area, which is pi r squared h. Base area times the height, which is pi r squared h. But if we are to take note here, we do not have this formula in terms of one variable. It's in terms of radius, in terms of height, whereby we know that the diameter is simply 2 times the radius, the diameter, meaning to say radius is diameter over 2. But in this case, we have an expression that we have between the diameter and the height, and we can remove this height here. We can simply make h the subject from this formula. H is equal to 6 minus d. So meaning to say our formula for the volume is going to be given as pi r squared into h, whereby our h is 6 minus d in this case. But like I said, the diameter is equal to 2 times the radius, meaning to say our volume is going to be given as pi r squared into 6 minus the diameter in terms of radius, which is 2r. So this expression for the volume now, it's in terms of the radius. So we're now having our volume in terms of the radius in this case. That's the idea. So expanding this part, we are having our volume in terms of radius, multiply here by pi, we are going to pi r squared, we are going to have 6 pi r squared in this case on this part. Multiply by pi r squared, we are going to have minus 2 pi r to the exponent of 3. This is same as 1. So this expression of volume with respect to the radius is enough for us to know the conditions that will make the volume to be maximum, because we are saying for this volume to be maximum, its derivative of the volume with respect to the variable that you are left with, which is the radius, in this case must be equal to 0. So we are simply differentiating here 2 times this, which is going to be 12 pi. Remember, we multiply by the exponent, then you subtract 1. So it's going to be 12 pi. All right, sorry for this. Let me just change. So it's going to be 2 times this, 2 times this 6, which is going to be 12 pi. We subtract 1, so it's going to be pi r there, minus, we do the same, the exponent multiplies here, so it's going to be 3 times 2, which is 6 pi r. We subtract 1, which is going to be a 2, so that's going to be minus 6 pi r squared. So this is the first derivative of our volume with respect to the radius, and it must be equal to what? It must be equal to 0, meaning to say we have formulated an equation that we can use to solve for the radius. In this case, we can transpose this part, or we can factor out what is common, because here we've got 6 pi and r, so we can factor out 6 pi r. That's going to be 12 divided by 6. This one, 12 and 6, that's 2 pi and pi cancel, r and r cancels, minus 6 and 6 cancels, pi cancels, r squared and r, that's going to be minus r there, which is equal to 0. So from the 0 concept, it states that this must be equal to 0, or this bracket must be equal to 0. So if 6 pi r is equal to 0, or 2 minus r is equal to 0, what does it mean? It means if we divide by 6 pi, our radius is going to be 0, or transpose this to the other side, it means our radius is equal to 2 in this case. But we are talking about a condition whereby this volume has to be maximum, and radius cannot be equal, meaning to say there's no movement, there's nothing there, so our radius cannot be equal to 0 in this case. So we are going to have the value of radius being what? Being 2. And the units there, we are talking about centimeters, so meaning to say this is radius in centimeters. So our radius was going to be 2 centimeters. But the question is, we are supposed to calculate the dimensions of the cylinder that ensure maximum height. So which dimensions? Remember, we are talking about the diameter and the height, the ones that were given before. So we are going to find our diameter, which we said is 2r. So our diameter is going to be 2 times the radius. Remember, we got our radius here as what? 2 centimeters. So that's going to be 2 times 2 in this case. Therefore, our diameter was going to give us 4 centimeters. And also, we have got the height. Remember, we are given that if we add the diameter and the height, you must get 6, meaning to say the height is equal to 6 minus the diameter. So in this case, we are going to obtain the height. The height is going to be 6 minus the diameter, which is the height is going to be 6 minus our diameter, which is 4 centimeters in this case. So that was going to give us the diameter, the height in this case of what? Of 2 centimeters. All right. So these were the dimensions according to what you are given, to the information, the diameter and the height. Those were the ones that we have from our cylinder to be maximum, the volume to be maximum. The question there was the volume to be maximum. So that is what you play around with. Then we can be given normal questions, which is not even about volume of area. You might think that is only about volume and area. They can give us normal numbers, just like this part. Find the 2 positive numbers. In this case, we need 2 positive numbers whose product is 750. So these 2 numbers, they have a product of 750. So we do not know these numbers. Let one be x and let the other one be y. The product of these 2 numbers must give us 750. So there we are talking about what? About the product of the numbers. Then for which the sum of one number and 10 times the other is mean. Take note, guys. We need to understand this question very, very much. It's not the product that we have to consider here, which is supposed to be minimum. No. For which the sum, for this is the condition that you're for now from this information, the sum of one number. If I consider my first number to be x, it means I'm going to have x plus, that is the sum, 10 times the other number. So it's going to be 10 times the other number, which is y. That is the sum. If I consider my first number to be y, it's going to be y plus 10 times the other number. The other number is x. So it's going to be 10x like this. So these were the 2 expressions that we are meaning to say. These expressions that we have, they are supposed to be minima. They're supposed to be minimum. So which condition are you going to work with? All right, I'm just going to take the first part here. X plus 10y is x plus 10y for the sum. So we are saying our sum of the first number, it's x plus 10y, 10 times the other one. So this is the expression for the sum that I'm going to choose to work with. Like I said, you can even use the second one. So with this expression for the sum, they are saying this sum that we see here has to be minimum. All right. So meaning to say we are having an expression for the sum in terms of x and y in this case. Our expression for the sum is given as x plus 10y. And it must be minimum, meaning to say its derivative, talking about the derivative of this sum, must be equal to 0. But with respect to what? That is where we have to choose either with respect to x or with respect to y. So we are supposed to make a substitution because this sum is in terms of x and y. So where are we going to have a substitution from the product? Because it's an equation that you are given there that you can play around, either to make x the subject. If you make x the subject, it's going to be divided by y, it's going to be 750 over y. If you make y the subject, it is going to be 750 over x squared over x. Whatever that you want to make the subject, you can make it the subject. But what is important is that here, if you check, y is already the subject. I mean, we already have a part that has got y here. So you can make x, there's no need for us to multiply anything to this x that we can make this up, because we are just substituting our x as it is. We just find the derivative. We are not going to multiply by 10 or this and that. No, there's no multiplication. So, but you choose whatever that you want. So in this case, I'm going to choose the first one. So meaning to say, we shall have the expression for the sum, which is s, in terms of y. The moment we substitute x here in terms of y, because this x is in terms of y, it's 750 over y like this plus 10y. We are now having the expression for the sum in terms of y. This was just an expression for the sum in terms of x and y at the same time, but now we just need this in terms of what? In terms of one variable, either in terms of x or in terms of y. So here I choose to use y. So once we have this, let's consider for this to be minimum. Now, what is the consideration? The first derivative of this expression for the what? For the sum must be equal to 0. So you're supposed to differentiate. 750 over y is same as what? 750y to the exponent of -1. So we are supposed to multiply -1 times 750. That's negative 750. We subtract 1 minus 2 in this case. So it's going to be minus y squared. Then here's a linear expression. The derivative of 10y is going to be a 10. And this is equal to 0 because we are saying the derivative of this whole part must be equal to what? Must be equal to 0. So we are supposed to solve for the value of y in this case. So how can we solve for y? Transpose, in this case, we're going to have minus 750 over y squared is equal to 10 to that side is going to be a negative 10. So since we've got a negative cancels, then we can cross multiply in this case to find y. You can just cross multiply. That's 10 times y squared, which is going to be 10y squared. It's 1 times 750, which is 750 in this case. We can divide by 10 by 10. That means our y squared is going to be equal to what? Y squared is going to be equal to 75. For us to find the value of y, is simply going to introduce the square root in this case. So y is going to give us, from this part, y was going to give us 5 square root of 3. All right, that's going to be 5 square root of 3 in this case, or as a decimal, it was going to be something like 8.66. That is, we are taking a positive because remember the square root of a number is plus or minus, but here it's saying two positive numbers. They did not say whole numbers. They just say positive numbers. So it can be a decimal as long as it's a positive. So we are not going to take the plus or minus concept. We are just going to consider the positive value because we are told that this is supposed to be a positive value. So this is the first value of y that we have, which is going to be 5 square root of 3 or this 8.66, whatever that we have. So to find the value of x, where are we going to have our x? Because the question here is not for us to determine the minimum value. No, we need the two numbers that will make this minimum. So already, if we check here, we've got an expression for x. X is equal to 750 over y. From this one, we made x. We said x is 750 over y. So meaning to say, we are simply going to make a substitution where there is what? where there is y, we're going to substitute our y in this part where there is x. So meaning to say our x was going to be 750 over y in this case, which is this one that we got 5 square root of 3. So that was going to give us the value of x, which was going to be 50. We are going to obtain 50 square root of 3 on this one. It was going to give us 50 square root of 3 or 86,66 and so on. So this is how we play around with these typical questions. All we need is to make sure that we revise as much questions as we can see. That is the concept. So that is it, guys. Let's continue to work more questions.